Okay, I'm recording, so welcome everyone. We're going to go over the chapter ACLs. ACLs are difficult, and it's how all firewalls work. So we're going to learn what firewalls and actually how they work. So the layer 4 TCP is a very important layer. It's going to have the TCP, which is guaranteed delivery, and the UDP, which is non-guaranteed delivery. And you're going to do the three-way handshake, where it syncs, acknowledges, and then through the process, if they don't get all the segments, it will actually resend them automatically. That's what the layer 4 does. And also in layer 4, we're going to do packet filtering. So a router will filter packets or deny packets. So that's what we're going to do tonight is write statements. In the criteria for filtering, so packet filtering, which is also called access control list. Way back when they called them conduit. So that's what they used to call them. But you can filter traffic on protocol, source and destination IP address, source and destination port number, whether the state is established or the type is echo reply. And then you can see I put in there the precedent TOC log. That comes into play on an obscure question. So here's a nice flow chart for packet filtering. Basically what it's going to do is going to read each line of the ACL one at a time sequentially. Once it meets a match, it will act on that particular statement. ACLs are placed at the router interfaces, and they can be an in or an out interface depending on where you place them and depending on if it's a standard or an extended ACL. The 3 Ps, you can filter one ACL per protocol, one ACL per interface, and one ACL per direction. So we're going to deal with that. So sometimes you have to let the data stream out, and you also have to let it back in. But you can also block that. You can let it out and block it on the in. So this is a standard ACL, and it's standard because we'll cover this in a little bit. It's got a number to it, and it's reading ACL list or access list 10 permits 192.168.30.0, and then we see the wildcard. And if you remember what the wildcard is, it's the complete opposite of the subnet mask. So basically, if you take 000.255 and subtract it from the subnet mask, which is 255.255.255.0, you see the inverse mask. Also, the second is we're going to talk about extended ACLs. Standard ACLs only block or permit source traffic. So the extended is going to block source and destination with protocol. And so you can see it's a little bit longer ACL statement here. So it's access list 103, which means it's extended. It's going to permit TCP, IP, wildcard mask, and the destination would be any. And there's another way to write any, which is 255.255.255.0, 255.255.255.0. Or you can write the word any. EQ means equal, and port number is 80. So we can either number them or name them. Numbering came first, and they had these numbers said that if it was an access list had a number of 1 to 99, it was standard. If it had an access list of 100 to 199, it would be extended. So name came next, and so now we're able to name them. So we're going to show that in a demo lab. Placement of the ACLs. Standard, you generally, place it closest to destination. So you have to look at the data stream, and we'll cover a little bit more of that when we talk about them. But I want you to realize that you can put ACLs on incorrectly and do the inverse effect of what you wanted. Placement of extended, or generally place them closest to the source. So once again, you look at the data stream, what's the source, what's the destination, and that's how you choose So extended, source, and then standard is closest destination. So here's your best practice for ACLs. Base your ACLs on the secure policy of organization. Okay, those are all good things, and that shows you the benefit. Entering criteria statements. So we're going to do these together, but you're going to have to read them almost like a story problem. So ACL 101 is a complete separate ACL, and ACL 102 is a complete separate ACL. ACL 101 is actually permitting, because it's an extended, so the number 101 means it's extended. It permits IP, and because it has a wildcard mask of 00255, it's any IP that starts with 192.168.10. That's the source. Destination is going to be the 192.168.30. So we're permitting network 10 to go over to network 30. And that's first ACL. In the second ACL, we're permitting the 10 network to go back to the 30 network. And then you can see that there's an access list 102 deny IP any. So you must remember that even though the ACL 101 does not state deny any, every ACL has a statement. It's implied that you have a deny any. That's just in case you mess up and you catch something slipping out on that last statement. So here's your syntax for this is how you do your wildcard, and it's very simple. It's the inverse of your subnet mask. And in class next time, I'll do the shortcut. Remember, if you're incrementing, if you're subnetting, it's one less in your increment, and that's your wildcard mask. So once again, if your subnet mask is 128, the wildcard would be 127. If your increment is 64, it's 63. If your increment's 32, it's 33, and so forth. So first of all, you write the ACL, and then you have to apply it to an interface. And you have to apply it to the interface in or out, and you want to base it off of either standard or extended. So you can see here that the access list is going to permit 192.168.10.0 with a wildcard 00255. So it's just permitting that. And you're going to put it on that fast Ethernet, so it's going to go that direction. Once you get in fast Ethernet, you have to apply IP access group 1 out. So if you look at the fast Ethernet 00, it's going to let the traffic flow out, coming from the other network here. So we're in router 1, and we are applying to fast Ethernet 00 out. So traffic is allowed to come from 10 out. If you number them, we're also going to cover this. You really want to do the numbered one, because if you make a mistake and you got to put another line in between, when you do numbered only, you have to completely eliminate the access list. So you have to completely remove it. So I often, can you see the notepad here? It's got my ACL written on it. Perfect. Thank you for responding, though. So this is the access list that I was working on for this. It's pretty extensive, so we're going to play with this. It's not completely working, and that's generally what I find with my ACLs. It takes a while to really get them to go and understand and get them to work. You can comment. So comments are going to be where it says remark. So there's all kinds of comments when you code, but this one is actually remarks. So you can actually, and it's very beneficial for someone coming behind you and reading your ACLs, because then you can actually write them in regular words what your ACL is doing. So it's commenting. So here's an example of a named ACL. We're going to do this together. And when you want to monitor them, you do show access list. And it's very interesting, and we'll show this later. You can actually see the matches here. So that extended number 10, line number 10, it's 25 matches it. So someone's trying to telnet, and they're being permitted. So it actually gives you some statistics on what your ACLs are actually doing. And then you show access list, and you can see those once again. And in the middle there, they went back into config T to actually do IP access list standard, create another one, and then show. So you can see that you can keep adding access list also. Extended access list, and this is the point where you're going to have to start memorizing the port numbers. So you need to know that 20 is FTP data, 21 is FTP, and telnet's 23. And there's many others we want to learn. So once again, extended, you're going to place on an interface, and extended is closest to source, standard is closest to destination. Now that's a general rule. It says we want to thoroughly test our access list. So once again, you can see this named ACL. Extended or standard? Well, it says extended. So this is a named extended. It's called surfing. And remember, spelling capitalization and spelling count. So if you spell surfing or do not uppercase, lowercase, and apply on your interface, it's not going to work. There's 3 types of complex ACLs: the dynamic, the reflective, and the time-based. And the first one means that users have to telnet into the router before allowing them to get through the router. And that's not going to be it's not going to be practical for most companies to teach your employees how to telnet. You have the reflective ACL. So what that does is allows outbound traffic and limits inbound traffic. So you can let all this traffic out, but then when it comes back, it's going to be limited depending on what went out and how it went out. And then you have your time-based. So this is going to be based on time of day, time of week. So if your company only operates from 7 a.m. to 5 p.m., then you may have ACLs, covering that 5 p.m. to 7 a.m. So just to lock down the network a little bit more. Dynamic ACLs, you can see here. So I'm going to go through these. It's a little bit easier when you see it through the lab. But these are the steps. So this one here is actually doing access list 101 permit host to telnet. So this is just allowing one computer to telnet into that router. And that's probably a good practice for most companies. And then you can actually apply it to the line VTY04. Then you actually do that in one of your packet tracers. Reflective, here's an example of reflective. We're not going to configure any of these, so just know the 3 types. You're not going to have to know. And everybody can say hi to Mr. Bruner. He just walked in. It's on the record. Then your time-based. You can see an example of that. We're not going to do any of these, but you possibly would run into them a little bit later. Troubleshooting, we're going to do on our own. So these are just things you can go through. But we'll cover that. And there's your summary. So we'll cover the troubleshooting as we do the lab that I'm trying to get to work. I'm going to stop recording now.